I've spent late nights trawling through every paper, preprint, telescope log and sober rebuttal I could find about an object the skywatchers began to whisper about as 3I Atlas. What I'm going to unfold for you tonight isn't breathless or sensational. It's a calm glide through evidence and careful inferences that, when set side by side, ask us to loosen our grip on what we were sure we knew about visitors from between the stars. After immersing myself in the full record, peer-reviewed analysis, fitful forum debates, and the thorniest arguments that made even Harvard astronomers pause, one thing became clear. 3I Atlas is stranger, subtler, and more provocative than anyone first suspected. We'll explore why its path seemed to sneer at astronomical odds, why the James Webb Space Telescope reported spectral hints that don't sit comfortably inside the tidy box labelled Ordinary Comet, and how a bright, controversial physicist managed to convince a hefty slice of the internet that we might be watching a reconnaissance craft sweep, quietly and professionally, through our neighbourhood. But that is only the first page. The more gently we sift the data, the more the mystery deepens. A precisely timed vanishing behind the sun, a flurry of theories that flamed and cooled with every new observation, and a puzzle that somehow remains both grounded and astonishing. Before we set off, allow me one soft request that won't disturb the mood. If you enjoy unwinding with slow, thoughtful journeys through cosmic puzzles, please subscribe to and like Space Historian. It helps this little observatory of the mind keep its lights warm, and it tells the algorithms you want more gentle space stories to fall asleep to. Now, take a long, easy breath and let's begin. On the 1st of July 2025, at exactly 11:37 Coordinated Universal Time, a robotic telescope high in the Chilean Andes caught something unassuming. The Asteroid Terrestrial Impact Last Alert System, Atlas, whose name often feels like a wink from the universe, was sweeping the night like it always does, netting faint points of light and plotting their movements against a background of stars that hardly ever change. One dim pixel tugged at the software just enough to deserve a label, nothing more, a 1PL3Z. Coordinates were logged, brightness tucked into the ledger, the way thousands of numbers doze into a database every night. And yet again and again in astronomy, revolutions arrive disguised as routine entries. No trumpets, no headlines, only the careful choreography of orbital mechanics and the incredibly patient travel of photons making landfall on a sensor. A FED, a file, a quiet note, seen. Within hours, other eyes were on it. Observatories around the world added their dots to the map. The motion was brisk, sharper and more emphatic than you'd expect from anything comfortably pinned to the sun's gravity. The curve through space was hyperbolic, that telltale signature of an interstellar passerby, not born here, not staying long, only visiting. That was familiar. Since 2017, we'd learned that such wanderers existed, and yet almost immediately, something about this visitor resisted easy filing. Astronomers combed backwards through their archives, the way you rewind a security camera to spot when a stranger first walked past your door. There it was. 3I Atlas had already been photographed multiple times as far back as the 14th of June. The Zwicky Transient Facility at Palomar had recorded it. Other Atlas telescopes had too. These earlier frames revealed a different kind of surprise. It had been slipping towards us for weeks, perhaps longer, without setting off the alarms. Hidden in plain sight, camouflaged among the million pinpricks. That delayed recognition humbles us. How many other travellers are gliding through our outskirts, so faint and mannerly that we only notice them after they've tipped their hat and nearly passed. With the mathematics sharpening, the comparisons began. In 2017, we met Oumuamua. Small, dark, oddly elongated, and confounding in its non-gravitational acceleration. In 2019 came 2I/Borisov, more like a textbook comet, volatile, exuberant, yet hailing from another star. 3I Atlas seemed to occupy a middle ground that was paradoxically more puzzling than either extreme. Larger than Oumuamua, at least at first glance, but when it came to comet-like activity, it behaved as if underlining its points very lightly, enough to be noticed, not enough to be fully known. Early size estimates were generous, roughly 20 kilometers across, making it the largest interstellar object yet found. Then the numbers began to shrink. 10 kilometers, 5 or 6. Some teams hinted it could be only a few hundred meters wide. This shrinking act is not a trick, it's the geometry of uncertainty in action. We try to weigh a shadow by its dimness and a light beam by how it wavers. Interstellar visitors often sit exactly where our instruments are most easily fooled. Yet perhaps the most provoking part of 3I Atlas was not a measurement at all. It was a path. As the trajectory solution stabilized, researchers noticed a pattern that made them lean forward. This object was not merely barging through the solar system, it was threading a route, a sweeping tour touching, with curious intimacy, 3 of our most significant worlds. It would skim within roughly 29 million kilometers of Mars, carve a similarly close arc past Venus, and meander near Jupiter, the shepherd whose gravity edits so much of the outer system. The odds of a randomly oriented interstellar drifter happening to pass so near all 3 worlds? On the order of very small, 1 chance in several thousand by some reckonings. Not impossible, but eyebrow-raising. And when something in the sky raises both eyebrows at once, the imagination wakes. It awakened in a world newly willing to entertain difficult possibilities. Government reports on unidentified aerial phenomena had been published. Hearings had been held. A conversation that once lived on the fringes was now, at least in outline, permitted at the table. Into this climate stepped a familiar figure. Professor Avi Loeb of Harvard, admirers say he is bold, critics say he is provocative, both agree he is difficult to ignore, had already argued that Oumuamua's odd acceleration might be consistent with an artificial origin. His stance is simple to state and tricky to dismiss. Extraordinary ideas are allowed in science, provided they accept the same discipline as ordinary ones. Don't snicker. Test. 3I Atlas looked like a chance to apply that discipline anew. A remarkable trajectory, puzzling brightness and size, a cultural moment primed to wonder, a perfect storm for thinking in public. Before the arguments gather, it's worth taking a quiet detour to admire what any interstellar object represents, even if it proves to be nothing more exotic than rock and ice. Imagine a traveller that has drifted for millions, perhaps billions of years. It has passed through star-forming clouds and deserts where the temperature bottoms out near absolute zero. It has worn the winds of suns that flared and died long before ours lit. Its atoms carry a chemical accent from a stellar nursery that might be so remote we'll never see it directly. And then, for a handful of months, it wanders into our sky, and we get to whisper questions at it from afar. The first close looks at 3I Atlas brought a handful of quiet curiosities. Active comets usually bloom. They grow a diffuse coma, sometimes a tail, as volatile ices warm and sublimate. This visitor did develop a coma, a fuzzy envelope of gas and dust, but it seemed compact, almost polite. The outgassing did not roar. It hummed. Spectroscopy, our favourite trick for reading chemistry at a distance, tried to catch the telltale lines of water and carbon compounds and other usual suspects. The signals were there perhaps, but faint, as if the object were keeping its vowels too soft for us to hear clearly. Compared with 2I/Borisov, which played by the rulebook chemically, 3I Atlas felt coy, enough to reassure us it wasn't bare rock, not enough to let us proclaim its origins with confidence. Word of these anomalies leaked into the public garden with unusual speed. Social feeds hummed. Amateur astronomers tuned their gear and their hopes. Writers, futurists, and a few architects of fictional worlds began to sketch scenarios. The conversation had matured since 2017. It wasn't purely sensational. Many more people now knew what a spectrum is, what a fit residual means, how orbital solutions converge and go wrong. That maturity helped, and it also added pressure. The normal rhythm of science prefers long breaths and second drafts. The news cycle prefers crisp quotes. In between, people in domes and control rooms kept working. Hubble was penciled in to look. James Webb would sniff in the infrared, where warm dust and ices murmur their truths. The community expected, quietly, cautiously, that these instruments would decide the matter, and in a way, they did. They brought clarity and texture. They also sharpened the puzzles. The coma was real but unusually tight, neatly symmetric, not advertising a grand streamer of dust. The brightness varied, but not in a way that a simple tumbling potato of a nucleus explains neatly. The chemistry spoke softly. Meanwhile, the ephemeris charted an inner system tour with opportunities for remarkable study. A near pass by Mars in early October, tempting for any orbiter with a camera. Perihelion on the 30th of October, at roughly 130 million miles. But then a wrinkle worthy of a storyteller's pen. At perihelion, Earth and 3I Atlas would be on opposite sides of the Sun. For a stretch when heat would tease out the most revealing behaviour, our lines of sight would be sealed by the star that makes all our seeing possible. Some found this deliciously suspicious. If you were trying to pass through a busy planetary system without telling the nosiest inhabitants too much, wouldn't you prefer to have your most revealing moments occur out of view? To be clear, geometry can serve coincidence more often than conspiracy. But when details gather in suggestive clusters, people start to design thought experiments. Loeb and colleagues began one such exercise, careful to label it as that. A pedagogical framework, not a proclamation. Suppose, they asked, you were searching for examples of extraterrestrial technology. What clues would you watch for? An interstellar object with a choreographed path past key worlds would make a useful platform. Disguise it in natural clothing, dust, volatile ices, so it reads as a comet to first order. Let it absorb and transmit, measure and map. Skim Mars and Venus to take their temperatures and their atmosphere's pulses. Glance by Jupiter to taste the outer system's dynamical heartbeats. Glide across Earth's lane with a full view of the bright planet and its noisy technosphere. Then lean behind the Sun, where telescopes can't pry, to perform whatever maneuvers would most betray an engineered interior. Is it true? Far more likely, the team said plainly, that 3I Atlas is natural, but they insisted on something that feels new in the culture. Treat the artificial hypothesis as testable, not taboo. Write down what it would predict, list observations that would count against it, then take the data as they come. This shift matters because it expands the search for life from radio calls and biosignature gases to artifacts, things. If there are relics or probes in the gulfs between stars, then astronomy becomes, on some days, archaeology. A field expedition undertaken with telescopes and spectrographs rather than brushes, but archaeology nonetheless. Back on the mountaintops and in control rooms, the work carried on. Coordinates tightened, photometry improved. Teams compared notes on rotational light curves, searching for a spin period that made the flicker make sense. Hubble's pictures, small, elegant, humbling, became the public face of the object. The symmetry of the coma, its stubborn compactness, the lack of an obvious tail, all of it sat on the table like a riddle whose clue you can't quite remember. The result was a kind of suspended certainty, enough normal behavior to keep the natural comet box ticked, enough quirks to leave the more speculative file open. The science proceeded with multiple working hypotheses, a phrase that sounds boring and is actually brave. The narrative in the wider culture grew more sophisticated as well. Reporters learned to say non-gravitational acceleration without tripping. Readers learned to be patient with error bars. Government offices paid attention discreetly. Universities found themselves drafting lesson plans for a paradox: how to teach healthy skepticism alongside intellectual hospitality to what might be true but not yet proven. Underneath the commentary, larger questions hummed. Are we alone or merely early? If intelligence is common, how would its artifacts look from a distance? What responsibilities come with suspecting that we are seen and perhaps studied? And just as importantly, how do we protect science from our favourite stories, even when those stories are beautiful? To appreciate why 3i Atlas hit a cultural nerve, it helps to glance at the history of our searches. For decades, we listened with radio and looked for life with chemistry. SETI dishes on the one hand, telescopes prying oxygen and methane from exoplanet atmospheres on the other. In the late 2010s, a third track began to take shape. Techno signatures not only as beams or flares, but as objects. Structures, probes, debris, beacons, any physical thing that betrays intention. Oumuamua was the catalyst. Its oddness made respectable people ask impolite questions, and those questions never quite went away. Even after many experts settled on exotic outgassing as a natural explanation, the idea that interstellar space might carry a small population of made things had landed. That idea changed how we look. An asteroid with an impossible spectrum, a comet whose coma seems architected, a meteor whose isotopes sing the wrong tune? Don't assume. Check. If the galaxy has been busy for billions of years, it would be odd if it had left nothing behind. Perhaps the sky is full of messages that never meant to be messages at all, only tools, waste, or echoes from someone else's errands. So when 3i Atlas came along, timed oddly, measured tentatively, behaving politely wrong, it offered a case study for this new mindset. Not a proof, not even a likelihood, a chance to practice. The calculations that followed were, in their way, a form of meditation. You trace a path backwards through time, let gravity have its say, let uncertainties breathe, and then ask what fits. Most interstellar visitors are sloppy in their orientation relative to planetary planes. They arrive like a guest who has not seen a map of the house, stepping where the furniture happens to be. 3i Atlas, by contrast, seemed to have memorized the rooms. With each refinement of the orbit, the pattern held. An approach that looked less like happenstance and more like a survey plan, a route that, if you were designing it, would give you good looks at the interesting places for the least expenditure of effort. In short, it appeared to be following what could only be described as an optimal reconnaissance trajectory. Its journey threaded the inner system with a tactician's grace, slipping past worlds at ranges perfect for close study, while keeping its tilt modest, near the broad, flat boulevard of the ecliptic where most of our solar traffic circulates. If someone had sketched an ideal survey route for learning as much as possible with the least commotion, they would have drawn something uncannily like the course 3i Atlas appeared to be following all on its own. From that realization grew one of the more engrossing thought experiments in recent astronomy. Professor Avi Loeb and colleagues gave it a simple name: the reconnaissance hypothesis. What if, they asked without theatrics, 3i Atlas were not a happenstance wayfarer, but a purpose-built surveyor hiding in the open? The case they outlined didn't hinge on a single flourish, it was layered. First came the path itself, statistically odd in its efficiency. Then the photometry and size-brightness behavior, suggestive of something larger or more reflective than a garden-variety comet nucleus. And then, perhaps most beguiling, the timing. The middle of the 2020s is an in-between era for us. Our telescopes and algorithms are good enough to notice interstellar passers-by and pick at their spectra, but our in-space infrastructure is still limited. We cannot easily chase, orbit, or intercept. If an intelligence wished to check on our progress, observe our radio chatter, sample our satellite belts, watch how our agencies and academics respond to a puzzling visitor, this would be a low-risk window, close enough for them to gather what they need, distant enough to remain ambiguous to us. To their credit, the researchers framed all of this with scientific manners. They did not declare 3i Atlas artificial. They argued that the artificial hypothesis deserved equal-time testing beside natural explanations. At the edge of the known sober method demands we carry more than one idea in our heads at once and let the data choose, eventually, which survives. Not belief, not scoffing, a patient duel between hypotheses. One strand of thinking braided into this discussion comes from a somber corner of theoretical astrobiology, sometimes nicknamed the Dark Forest View, popularized in fiction by the author Liu Cixin. It offers one stern answer to the Fermi paradox, the old question of, where is everybody? In a galaxy where contact can carry existential risk, civilizations keep quiet, watching more than waving. Under such rules, reconnaissance is survival. If that's the game the galaxy plays, then a probe masked as an ordinary interstellar comet would be a prudent instrument. It could monitor atmospheres, magnetospheres, telecommunications, and space traffic while preserving understatement, a design that invites study yet deflects certainty. Even if we pointed our best observatories at it, ambiguity would remain its camouflage. In that light, the peculiarities around 3i Atlas become easy to narrate. The trajectory reads like navigation, not luck. The muted coma looks like restraint. The calendar feels chosen, not rolled from a cosmic dice cup. And still, speculation is not a substitute for a spectrum, so the observing campaign pressed ahead. The summer of 2025 turned into a choreography of domes and dishes. Schedules realigned. Night crews compared notes across time zones. Telescopes in the Atacama, Mauna Kea, Palomar, everywhere a clear sky could be bribed into cooperation, took their turn. It was the kind of global cooperation that science does best. Patient, collegial, and quietly heroic. Hubble's look on the 21st of July brought the first truly iconic frames. They confirmed a coma, gas and dust whispering from the nucleus, but the shape was tidy. Instead of a long teardrop tail torn away by the solar wind, the surrounding glow appeared compact and nearly symmetric, a gentle halo rather than a streamer. That geometry spawned conversations. Perhaps the nucleus spins in a way that smears out the flow evenly. Perhaps surface layers throttle the vents. Or, if one wants to court the wilder idea, perhaps the outgassing is being modulated to keep appearances comfortably comet-like without telling the full story. Hubble also caught subtle brightness ripples, too small to map as features, but enough to hint that the surface isn't uniform. The difficulty is that even our sharpest eyes reduce 3i Atlas to a bright point wearing a soft scarf. the miles of space between us and it forbid detail. Spectroscopists kept at their craft. They aimed for the signatures you expect when sunlight coaxes volatiles to vapor. Water lines, carbon compounds, the familiar bands that make comet chemistry legible. What came back was a whisper, not a chorus. The lines were there, then faint, then there again, always present enough to say comet, never loud enough to satisfy the modelers who wanted something textbook. Compared with 2I/Borisov, which sang cleanly in 2019, this traveller seemed to be murmuring through a glove. Explanations ranged from the domestically mundane to the outrageously interesting. Maybe the object formed in an ultra-cold outskirts where only stubborn ices condense, so it waits for stronger heat to speak. Maybe its skin has been altered by long ages under cosmic rays, sintered into a crust that stifles most venting. Or, if we momentarily keep the reconnaissance frame on the table, maybe the activity is being tuned to disclose just enough to look natural while keeping diagnostic signatures coy. Meanwhile, the community looked to our newest mirror in the sky. The James Webb Space Telescope was cued to watch in early August. Webb's superpower is the infrared. It can pick out warm dust and sniff out ices by their fingerprints with a sensitivity that still feels like magic. People were excited, and they were anxious too. Because it is one thing to entertain extraordinary possibilities, it is another to invite the sharpest instrument we've built to test them. Webb finally turned to 3I Atlas on the 6th of August 2025. Hours of spectra arrived, stitched across a wide swath of infrared wavelengths. The verdict was, beautifully, maddeningly, two things at once. Clear evidence of comet-like activity. Water vapor, carbon dioxide, organics. Yet the proportions were peculiar. The carbon dioxide towered in the data, dominating the chemistry in ratios far above what we've catalogued in solar system comets, or in Borisov before it. Some teams quoted a CO2 to H2O ratio of roughly 8:1. That's not a small tweak, it's a new accent entirely. Such an imbalance offers two roads. One says, here is something born in an unusually frigid nursery, a place where carbon dioxide froze readily and water was scarce or deeply bound. The other says, here is behaviour being managed, a veil lifted just so far with the visible gases chosen for effect. Webb also teased out isotopes, subtle differences in the weights of atoms that hinted at an origin around an ancient metal-poor star. If right, the object is older than our Sun by a wide margin, a reliquary grain from an era when the galaxy was still learning how to make complex elements. That age, whether the object is natural or not, adds a hush to the room. Cepherex joined the conversation soon after, mapping an immense CO2 cloud draped around 3I Atlas, sprawling hundreds of thousands of kilometers. The cloud wasn't even. It shifted and braided with time, as though driven by a complex rotation or a dance between sunlight and surface geometry, or by some process we have not yet had reason to imagine. Each instrument answered a question and printed two more. By late August, the portrait was paradox in motion. Yes, it behaves like a comet, and no, not quite like any comet we know. It lives in the borderlands between categories, familiar enough to calm, peculiar enough to provoke. That is precisely the region where our thinking tends to evolve. The theoretical work, meanwhile, didn't stand still. Loeb's group and others kept elaborating the reconnaissance framework, not to shout, "This is it," but to clarify what it would look like if it were. What observational hooks might separate made from born? How could a probe hide in the noise of natural behaviour? How would a cautious civilization time a survey to gauge us without sounding alarms? These papers were less about 3I Atlas and more about training. teaching ourselves how to notice artifacts should they ever drift through our nets. If you find this kind of measured wondering soothing as you drift off, it helps immensely if you tap like and subscribe to Space Historian. It keeps these quiet night journeys reaching the people who want them. Outside the journals and control rooms, the public conversation blossomed into something rare and rather lovely. Forums filled with orbital plots and code snippets. Amateur astronomers stacked images and compared photometry from back gardens and rooftops. Retired engineers dusted off dynamics textbooks. Students built little web apps to visualize the evolving ephemeris. It felt like a planet-wide seminar conducted under the same sky. All the while, the clock hand moved. Interstellar visitors do not linger. Perihelion loomed at the end of October, after which the geometry of the encounter would begin to unspool and our guest would fade. The urgency was real. Every night won by clear weather and good seeing was a gift. Every cloudy night was a small grief. The pressure was most acute for those who dared to imagine we were looking at technology. If so, this might be our only close view for generations. Resources were shifted. Telescope time was traded. Review panels moved unusually fast. Careers quietly hinged on the next data set. And yet, the object itself remained perfectly itself, unhastened, unbothered. Photometric flickers hinted at rotation, but the rhythm felt almost too regular for a rubble pile sculpted by blind collisions. The spectra stayed shy, lines rising and fading like breath. The trajectory went on being improbable without betraying any obvious course corrections. 3I Atlas occupied the narrow lane where the natural and the artificial both keep pace, neither pulling ahead, each still plausible. It was as if the universe had designed a riddle not to be solved, but to make us better at solving. By the turn into late summer, all eyes pivoted to the near-term milestone. The pass by Mars in early October. At a range on the order of 29 million kilometers, it would not be a rendezvous, but it was close enough to tempt every camera circling the red planet. Teams began to work the geometry problems: when to point, how long to expose, what filters to select, chasing the dream of catching more than a point and a halo. The high-resolution imager aboard Mars Reconnaissance Orbiter, famous for reading a spacecraft's logo from orbit, offered the best hope. A handful of hours, perhaps, to see 3I Atlas from a new angle as it slid from approach to departure. If luck and physics smiled, we might resolve structure or watch activity ebb and swell as the phase angle changed. Of course, the more speculative storylines followed closely behind. If the reconnaissance idea were true, if 3I Atlas were a watcher under a shawl, then Mars is exactly the sort of chapter you would expect in its brief field report. The red planet has never been more interesting to us. Rovers at work, orbiters mapping every dune and delta, architects sketching out the logistics of a human foothold. For an external intelligence, 2025 Mars is a laboratory full of labelled experiments and a shelf of prototypes for tomorrow. A close pass would let a careful surveyor sample atmosphere and dust, read surface mineralogy, take inventory of our machines, and measure the reach of our radio and laser links, while to our eyes, it would remain an interstellar comet dutifully minding its arc. In that frame, the Mars flyby shifts from a merely scientific opportunity to something more delicate, a moment that, if our wilder hypothesis holds, would amount to a quiet first look at us in situ. If 3I Atlas were artificial, humanity might be witnessing its first detailed assessment by an extraterrestrial intelligence. A quiet kind of awe settled over people as the idea took root. A cosmic inspection was underway, and it might be deciding how we look to minds from somewhere else. Social feeds hummed with late-night threads. What might 3i Atlas be hearing from our noisy planet? What rhythms of orbit and radio would describe us? What story would its data tell if it whispered a report across the dark to distant makers? In that conversation, another realization surfaced, gentle but immense. The encounter was turning our gaze outward and back again. It was asking us to imagine ourselves as someone else might see us, a species young and curious, inventive and untidy, still learning how to be careful with the powers it discovers. The self-portrait that emerged from this exercise felt as momentous as any spectrum or light curve. We were testing our place in the order of things, asking whether we were ready for a meeting we could neither arrange nor refuse, and whether we were the kind of witnesses worthy of the vastness we hoped to join. While that reflection deepened, the practical work intensified. Observatories on desert mountaintops and ocean islands stitched their nights together so that 3i Atlas would never slip from view as it slid from evening sky to dawn. Space telescopes cued their last safe looks before geometry and sunlight closed the door. It became one of those rare campaigns where the world's optics all bend toward a single point. Time was traded, programs deferred, plans rewritten with the kind of grace that only a shared purpose can summon. The logistics were a puzzle in motion. The object's track changed nightly, forcing constant retargeting. Its brightness rose as it drew in, demanding new exposure schemes and detector settings. Background star fields wheeled and shifted, complicating the patient arithmetic of photometry and the delicate art of spectroscopy, and yet the orchestration held. Streams of fresh data spilled into processing centers, where teams rotated through day and night, coaxing meaning out of raw counts and noise. It was a portrait of global discipline in service of a fleeting chance. By September, the visitor began to show more of itself. The cloud around its heart swelled and grew textured, asymmetries unfurling like soft braids, hints of jets or vents turning on and off with sunlight and spin. Spectra evolved with the warmth as different ices took their turn to breathe. Carbon dioxide remained the loudest voice, a keynote that set 3i Atlas apart from the comets we've catalogued at home. Then a rarer signature appeared, carbonyl sulfide. You don't often see it in our neighbourhood. It points to very particular chemical pathways and pressures, to formation histories that don't mirror the familiar. High-resolution measurements of isotopes kept pushing the same story. The material felt old, born around a star poor in heavy elements, ancient, even by galactic standards. In that sense, 3i Atlas was not merely a visitor, it was an emissary from a younger Milky Way, a time capsule of conditions that predate Earth's first stones. And still, the core uncertainty refused to budge. Every new detail could be read two ways. The rising activity as it neared the Sun could be simple physics, heat in, gas out, or it could be something coordinated, systems waking, behavior curated to mimic nature's script. The shifting spectral mix could be layered ices coming alive in turn, or a managed release chosen to keep the disguise convincing. The object kept its balance on a narrow ridge between stories, giving both just enough to live. This ambiguity carried a lesson larger than one comet-like point. It pressed against the edges of our instruments and our habits of mind. How exactly would we tell natural from made if the maker was millions of years ahead and deliberately choosing to blur the line? What counts as an unmistakable sign of intention when intention might prefer to hide? How do we hold our skepticism steady while leaving the door open to a world-changing yes? 3i Atlas showed us the calibration of our methods, exquisitely tuned for nature as we know it, less sure-footed when faced with categories that might not exist yet in our textbooks. For decades, we listened for messages and scanned for megastructures. Maybe, the object suggested, genuine encounters begin quieter, half in shadow, half in light, requiring new ways to look and new ways to argue responsibly. Public interest, already bright, flared as the calendar edged toward 2 dates everyone could circle. Early October, a pass by Mars. Late October, perihelion. News segments alternated between careful summaries and breathless guesses. Online, volunteers and veterans mixed. Retired aerospace minds posted shrewd trajectory plots. Backyard observers shared calibrated measurements. Coders spun up tools that let anyone animate the path and predict the glint. The delight of citizen science blossomed alongside its pitfalls. Good data and bold conjecture crowded the same feeds, and the pace at which assertions spread far outstripped the tempo of validation. It became a live exercise in modern scientific culture, how to welcome many hands into the work without losing the scaffolding that keeps conclusions reliable. Preparations for the crescendo tightened. The geometry was unkind and intriguing at once. Mars would host our best cameras for the close pass on the 3rd of October. Weeks later, on the 30th of October, the object would skim closest to the Sun. Only then it would do so behind the solar blaze, as seen from Earth, almost perfectly concealed. For the speculative crowd, the timing felt theatrical. For the cautious, it was simply the sky's indifferent mechanics. Either way, the hidden weeks took on an air of drama. If 3i Atlas were only ice and dust, it would surge and shed in darkness, then reappear changed by an ordinary ordeal. If it were more than that, the interval offered cover to do anything that didn't bear the weight of our watching. One possibility drew special attention. The Parker Solar Probe, the swiftest machine we've ever flown, sometimes skims close to the very space where our sight fails. Could its instruments catch some whisper, a brightness variation, a particle signature that overlapped with the concealed path? Teams ran the numbers. The practical hurdles were formidable. Parker is built to taste the wind of the sun, not to image distant small bodies. Its safety margins are tight by design. Still, the prospect that it might provide the only direct sniff of behavior during the blackout added a new thread of anticipation. Even success, everyone admitted, would likely be equivocal, signal to noise hard to pass, results inviting more interpretation than verdict. As October opened, Mars took center stage. The pass would be brief, measured in hours, but it promised the sharpest look we'd ever had. The HiRISE camera aboard Mars Reconnaissance Orbiter, famous for reading the fine print on hardware planted across the Martian deserts, was our best bet. Engineers and scientists rehearsed the pointing, vetted exposure times, argued over filters. When the window came, HiRISE looked. The processed frames, when they reached desks and screens, felt like unwrapping a long-awaited parcel. There it was, a compact, roughly spherical core wrapped in a delicate haze. Hints of an uneven surface, light and dark patches, suggestive but not decisive. The coma showed structure, faint streamers, small asymmetries that spoke of active regions turning in and out of sunlight. It was the clearest view yet, and it kept the riddle intact. The bright and dim patches could be geology or something arranged. The jets could be the breath of warmed ices, or a controlled plume kept within comet-like bounds. Each interpretation could wear the same picture. Debate, of course, bloomed. Some argued the images sealed the case for a natural origin. A comet is a comet. Others found in the details an invitation to keep the artificial hypothesis alive. Underneath those arguments lived older questions about evidence and extraordinary claims. What threshold must a sign cross before we name it? What's the right burden of proof when the conclusion would rewrite a century of assumptions? How do we keep our caution from hardening into reflex denial, or our wonder from running ahead of the facts? After the Mars chapter, Earth's vantage deteriorated quickly. The sun's glare swallowed the track, the angles grew mean. We knew that in days the object would step behind the curtain entirely into a private theatre of heat and wind where our instruments could not follow. If you enjoy keeping company with this kind of patient starlit wondering, feel free to like and subscribe to Space Historian. It helps these quiet journeys find the listeners who need them. In mid-October, with the last slivers of time left, observatories caught their final looks. The coma, now full and intricate, braided itself into patterns that hinted at either complicated venting or something stranger. Spectra added new lines to the score. Hydrogen sulfide, ammonia, a bouquet of organics. These species wake at different temperatures, yet some appeared earlier than models predict. Others lingered longer than they should. Thermal behavior wandered off script. Perhaps the surface was a quilt of materials and pores, layered in ways that shuffled the expected order of events. Perhaps a crust cracked and sealed in patterns that fooled our simple maps of heat. Or perhaps the show was paced. Photometry suggested a change in spin, slower than the rubble pile rule of thumb would propose for a body of this size and shape. Brightness variations hinted at either exotic surface patches or activity zones turning on and off with a rhythm that didn't feel random. If you were designing a surveyor, a leisurely rotation would be handy. Stable pointing for long looks, measured sweeps across targets. The timing of the flickers could be the cadence of instrument cycles, or it could be the mundane consequence of mass distribution and sunlight tugging at jets. The coin, balanced on its edge, refused to fall. By the 20th of October, a strange melancholy crept in with the schedules. We were losing sight just as the show was set to be most revealing. Natural comets tend to be at their most theatrical near the sun, tails unfurling, comae roaring, physics written large against black. 3I Atlas would live through that act in seclusion, and we would be left to imagine. For those who favoured the ordinary, it was an inconvenience. For those who entertained the extraordinary, it was the very opportunity they'd have chosen. The hidden weeks acquired mythic weight online. Communities devoted to UFO lore folded the timing neatly into their narratives. Of course it would vanish during the crucial scene, they said. Of course that's when deployments would happen, or small couriers would dart inward, or the track would nudge by increments too subtle to betray themselves later. The mainstream conversation stayed more grounded, but admitted a truth. Gaps invite stories. Even the careful among us felt the pull to fill silence with possibility, and so the world's mood rose to a high pitch as October lengthened and the object neared the sun's far side. Newsrooms ran explainers and wild takes. Classrooms wrestled with methods and metaphysics. How do you teach caution that isn't cynicism? How do you allow amazement without encouraging credulity? The whole episode turned into a seminar in how knowledge grows at the edge of what can be known. Multiple hypotheses kept pace. Resolution limits reminded us of their power. Culture and psychology showed their hands in the choices we found comfortable to make. Then, the last visible days. 3I Atlas looked even from afar more awake than ever, its veil thick and laced, its chemistry crackling with lines that made the practical theorists frown and the poets smile. Detectors registered molecules that don't usually sing together at those distances. Temperature dependencies misbehaved. Rotation and brightness drifted in tandem, as if the object were either settling into a survey stance or simply obeying quirks of structure and sunlight that we hadn't anticipated. Every explanation walked with its shadow. And finally, the calendar came to the threshold. On the eve of disappearance, There was a sense that the universe had composed the timing with a dramatist's ear. The curtain would fall just as the music swelled. Natural or not, the performance was perfect. The hidden transit sharpened every appetite, aggravated every doubt, and framed the simplest truth of observational astronomy. Sometimes the sky chooses mystery over mercy. As the last beam slipped around the sun and the object crossed into brightness we could not penetrate, conversations frayed into two strands, one scientific, one speculative, braided together by the same quiet hope. If it was a comet, it would blaze unseen and return to our gaze, altered in ordinary ways. If it was not, then the same weeks might carry deeds we'd argue about for years, with only circumstantial traces to guide us. Either way, time was short. The window was closing. The brief season when we shared a sky with a perhaps messenger had become a story we would finish in our heads before we could finish it with our instruments. And so the hidden passage became an emblem of our limits, our patience, our appetite for meaning. Universities turned the episode into living curriculum. Editors asked for essays about doubt and wonder. Observers watched the clock and checked the weather and wished for one more clear horizon. Whether 3i Atlas was someday judged a natural envoy from ancient starfields or something crafted, its transit had already changed us. It taught us what it feels like to live honestly with not knowing in a time of extraordinary tools and constant conversation. Now came the last visible frames before the eclipse, the coma thick with filigree, the chemistry oddly timed, the spin unhurried, the light curve tapping a rhythm that resisted our neat interpretations. October 20th arrived, and with it the knowledge that the next acts would be staged where we could not see. Perhaps jets would roar and ions would stream in the usual pageant. Perhaps other things would happen, quiet and careful and deliberate. The speculation sharpened as speculation does when facts retreat. Online, the timing was treated like a script excerpt leaked from a long whispered play. Communities devoted to sightings and contact theories treated the geometry as evidence. Of course the surveyor would choose that moment to turn its face elsewhere. Of course it would hide its best work behind the lamp of the sun. They saw in 3i Atlas the pattern they had long described, an approach masked as natural behaviour, a route that kissed the interesting places, a disappearing act at the crucial moment. It was, to them, the blueprint they had expected for genuine extraterrestrial contact. Ambiguity became the headline. Evidence that fit more than one story, timing that felt almost rehearsed, and official statements that kept a straight face, firmly cautious, never quite closing the door. The way people responded to 3i Atlas turned the sky into a mirror. The very same spectra, light curves, and orbital plots became Rorschach ink blots for our hopes and worries about our place in a crowded or empty universe. One reader saw coincidence and comet physics. Another saw intention and reconnaissance. What you believed before you looked up often wrote the caption under what you saw. Inside the observatories, the mood was steadier but no less complicated. The object was about to slip beyond reach just as it promised to be most revealing. That hurt. Astronomy is built for the patient and the permanent. Planets that keep appointments, stars that change on geological timescales. Visitors like 3i Atlas don't care about our schedules. They give you a narrow window, and sometimes that window doesn't line up with the instruments you most want to use. If, by some astonishing twist, this were our first brush with technology from elsewhere, then missing perihelion would mean losing the part of the story most likely to prove it. That sense of irreversible loss energized a new kind of conversation: how to be ready next time. The questions sharpened. What telescopes? What coordination? What analytics would let us capture everything a sudden visitor has to show? Where should we invest, and what should we be willing to pause so that the next interstellar guest is met with the best eyes and best minds we can bring to bear? The lesson was larger than any one object. Remarkable things can appear unannounced and leave before our best instruments can turn. Planning only for the steady and the predictable is a luxury we can't afford. On the 25th of October, as 3i Atlas began to slide behind the sun's glare, the last images were gorgeous and stubbornly enigmatic. The coma had puffed to its fullest, stitched with filaments and asymmetries that spoke of many active regions breathing at once. Spectrographs lit up with their strongest lines yet, confirmation that sunlight was shaking loose volatiles the way comets do. And within that confirmation, small misfits remained, ratios and shapes that refused to sit politely inside our neat models. Whatever else it may be, 3i Atlas knew how to be beautiful in exactly the way comets have always taught us to love the sky. Then the curtain came down. Direct sight was gone. Analysis took the stage. Teams huddled with months of data and asked every question data can answer. Modelers worked the chemistry, the heat flow, the microphysics of dust. Orbit fitters hunted for minuscule tugs in the path, tiny deviations a gravity-only trajectory wouldn't explain. Time series sleuths combed the brightness curves for rhythms that might betray rotation modes, vent cycles, or something stranger. A few hints surfaced as the weeks spun by. Some chemical signatures had drifted with time in ways that hinted at evolving interior layers or changing sunlight angles. The orbit solutions showed perturbations small enough to be swallowed by uncertainties, yet tempting enough to map over and over. The long arc of brightness carried periodicities that could be rotation, or could be seasonal lighting on an irregular body, or could be patterns our minds prefer to find. Whatever the truth, the object looked more complex on the second pass than it had on the first. That too is a lesson the sky often teaches. In that work you could see the outline of something else, the way the world had studied this thing together. Frames from Chile and Hawaii, Australia and South Africa, the Canaries and the Cape, all threaded into one file. No single dome could have kept vigil like that. The collaboration wasn't an afterthought, it was the method, and it turned out to be the only way to follow a guest, determined to be fleeting. Still, the central riddle held its ground. The data supported a natural comet with unusual quirks. The data also left enough room for more exotic readings, including possibilities we haven't yet named. That is not failure. It may be exactly what encountering the genuinely new feels like. Our categories sag under the weight, and we have to decide whether to shore them up or build different ones. As December neared and whispers spread that 3i Atlas would reappear in the morning sky, anticipation thickened. If it were purely natural, it should come back wearing the expected consequences of heat, brighter for a while, maybe changed by cracking and venting, the coma reshaped by wind and light. If it were something else, the aftermath might show it. A course nudged by more than gravity, a surface altered in ways that don't match heating alone, an activity pattern too precise to be weather. On the 3rd of December, the first telescopes to greet the dawn in Chile caught it, a faint seed of brightness in Virgo. Photometry suggested the object had been changed by its solar trial. Brighter than forecasts built from pre-eclipse behavior. Spectra confirmed continued gas release, with carbon dioxide still the loudest voice and water and organics following. It looked, in broad strokes, like a comet that had survived. Yet in the details, the old strangeness stirred. The brightening was a bit too generous. The relative intensities of the lines did not mirror the pre-eclipse mix. Perhaps the sun had scoured and resurfaced the nucleus in a way that changed what we saw. Or perhaps what we saw was being managed even now to keep the story leaning toward natural, while never quite letting us lock the box. High-resolution images from this reappearance showed a coma that seemed organized. Structures that looked almost geometric, like meshes or ribs laid into the haze. Natural physics can draw patterns, especially when a spinning body vents through fixed openings. But the regularity nudged imaginations. Supporters of the artificial reading had a new favourite slide for their talks. The cautious had a new phenomenon to model to exhaustion. As the object drifted outward, its behaviour softened. Brightness ebbed. The chemical bouquet simplified. In many ways, it was a return to the quiet it had worn on approach, a tapering that fit the Comet rulebook and yet in its smoothness felt meticulously paced. Natural processes absolutely can be smooth, they can also be surprisingly ragged. Which this was remained the persistent question. By then it was clear that 3i Atlas would be remembered for more than its chemistry or path. It had tugged research forward. Techniques for rapidly coordinating global observations, methods for teasing meaning from thin data, frameworks for keeping more than one explanation alive without letting the debate curdle. It had also reached beyond the journals. People who had never looked through an eyepiece suddenly knew what a hyperbolic orbit was. Enrollments in astronomy courses climbed. Museums drafted exhibits on interstellar visitors. The public conversation for once carried nuance. Individuals without formal training were building tools and models good enough to matter, and the scientific community found ways to sift signal from enthusiasm without crushing either. Out of the whole experience grew a plan to do better next time. Early warning survey systems need to be deeper, faster, wider. Data pipelines need to share openly by default when the sky presents a mystery. Fast turnaround scheduling across observatories needs to be not a favour, but a habit. And perhaps, most ambitiously, we need hardware ready to fly. Nimble interceptors that can be launched on short notice to pace, sample, and image an interstellar visitor from close range. The Vera C. Rubin Observatory will change the baseline by catching fainter, faster visitors more often. A large sample will tell us whether 3i Atlas was an outlier or one voice in a chorus we've only just learned to hear. Patterns that hide in singlets emerge in ensembles. If artifacts exist among the stars, statistics may find their fingerprints. There was one more lesson, as simple as it was urgent. The world needs a way to pivot. A creature of dust and ice, or of design and purpose, will not wait for our committee meetings. Readiness is a posture, not a press release. It means money where it counts, agreements signed before they're needed, and teams trained to move quickly without breaking the care that makes science trustworthy. In plain language, it means building rapid response capabilities when dealing with transient phenomena. For months it crept inward, unnoticed for what it truly was. By the time its interstellar origins sank in, some of the best chances to watch it in telling light and geometry had already slipped past. 3i Atlas taught a blunt lesson. Better telescopes alone aren't enough. We need faster thinking and faster choreography. Detection must be paired with triage, rapid classification that flags the unusual in hours, not weeks. Alert pipelines that ripple across observatories without friction. Checklists that turn a curious signal into a coordinated response before the sky turns the page. It also exposed the ceiling of ground-based watching. When a traveller's path carries it into the sun's glare or past angles that rob us of contrast, even the best mountains can't help us. The next leap may have to be in space. Missions built for surprise, able to pivot and sprint. Interceptors with engines that sip fuel sparingly, yet can bend their course on short notice. telescopes that can ride piggyback, then peel off to keep vigil when a visitor slips behind our star. The engineering brief is daunting. Fast launch, swift navigation, autonomous targeting, instruments hardened for heat and cold. But the payoff would spill far beyond interstellar objects. Build the muscle for a sudden chase, and you strengthen everything from planetary defense to heliophysics. As winter cooled the northern nights and 3i Atlas dimmed toward the threshold of our instruments, the worldwide circle that had formed around its study sat with the question that won't leave. What did we learn? About the visitor, yes, but also about ourselves. The stubborn ambiguity at the heart of the case proved two things at once. First, we can now peel astonishing detail from a faint, fast speck. Chemistry, isotopes, structure, spin. Second, even with that prowess, some phenomena are going to remain genuinely unresolved for a very long time. Understanding may advance, yet the verdict may refuse to arrive. That challenges a habit science sometimes slips into, the expectation that more data automatically means closure. 3i Atlas argued for a different discipline: carry parallel hypotheses with care, resist the easy peace of premature certainty, and cultivate patience not as a mood, but as a method. It also argued for crossing aisles. The teams that made the best sense of the clues did not fit in one department. Orbit fitters sat with spectroscopists. Thermal modelers compared notes with instrument engineers. Statisticians built priors and posteriors, while philosophers asked what exactly would count as a sign of intention if intention preferred to be shy. Psychologists mapped our bias toward pattern and narrative. The puzzle demanded all of them. The next puzzle will too. Beyond the dome lights, the cultural currents were just as revealing. A single visitor became a stress test for hopes and fears about contact. The same graphs were read as reassurance or alarm, proof of nature, or hints of design, depending on what each reader already thought the universe contains. That's not a failure of reason, it's a human baseline. But it means that if we ever face evidence that is less equivocal, we will need more than lab protocols. We will need diplomacy and law, ethics and education to keep the world steady while it digests something arguably bigger than any discovery we've made. How do you announce proof of other minds? Who speaks and in what tone? What does responsible skepticism look like when the stakes are civilizational? For now, the comet-like stranger moved outward and dimmed, slipping toward the dark it came from. The influence it left behind did not dim with it. Frameworks for classifying borderline cases grew sharper. Observing techniques were tuned for speed and for faintness. Archival searches began to comb old skies for the odd and the overlooked, and ordinary people, newly fluent in orbits and spectra, kept a warmer place in their minds for the possibility that the quiet between stars is not empty after all. Most of all, 3i Atlas refreshed a simple truth that can go stale in a catalogued age. The cosmos still surprises. Even now, with instruments of exquisite reach, mysteries can arrive, resist us, and leave. That freshness carries forward. What else is moving through the deep, brisk, and unannounced? How many travellers pass within our reach, with stories written in chemistries we have not yet learned to read? The horizon didn't shrink with this encounter, it stepped back. Practical plans followed the wonder. Survey programs sketched upgrades to catch more visitors earlier and flag the outliers with crisp confidence intervals. Rapid response observing protocols matured from ad hoc heroics into draft checklists: who calls whom, which telescopes pivot first, how data flow openly by default. Spacefaring agencies convene to talk hardware, pre-approved trajectories, off-the-shelf buses that can be tailored and launched quickly, instruments designed for both glare and shadow. educators folded the case into lessons on how science behaves at the edge of the map, how multiple working hypotheses are not weakness but wisdom, how collaboration scales, how uncertainty is not the enemy of truth but its necessary companion. In another register, the encounter lifted policy conversations out of abstraction. Budgets are statements of belief. If we believe visitors will keep coming, we ought to invest in eyes and hands that can greet them properly. The Vera C. Rubin Observatory promises to flood our nights with candidates. When it does, we will need systems that can tell the ordinary from the extraordinary in time to matter. And if these quiet night explorations help you drift and think, you're welcome to like and subscribe to Space Historian. It keeps these gentle voyages reaching the people who want them. Months slid by. The active surveillance eased. 3I Atlas retreated, but it stayed vivid in code and in memory. The debates did not resolve, they matured. Teams reanalyzed old meteors and comets with new tests, asking whether clues we now deem important were present in past data and simply went unnoticed. Several candidates rose from the archives. Odd trajectories, spectra that aged poorly into the ordinary once we stopped looking. Each will get a second look under better light. The most robust change, though, was structural. The international cooperation that had come together by necessity began to harden into standing agreements. Points of contact were named. Data formats were harmonized. Funding lines were proposed not for a single event, but for the inevitability of many. The shared aim was simple. When the next guest appears, we should behave as if we've been expecting it all along. Meanwhile, the story of 3I Atlas found a second life in classrooms and museums. Not as a tale of aliens or not aliens, but as a case study in how knowledge grows. Students learned to read spectra as sentences with clauses and caveats. They learned why a hyperbolic orbit matters and how error bars can be honest or misleading friends. They watched scientists disagree productively without slamming doors, and they practiced the unsettling art of sitting with unresolved possibilities without giving up on resolution. That may be the most durable education the sky can offer. The research legacy ran in parallel. Methods for teasing isotopic ratios from faint infrared features improved. Thermal models incorporated crusts and pores and layered ices that had once been treated as afterthoughts. Information theoretic tools for distinguishing pattern from wishful alignment found a home at the border between natural and maybe not, offering ways to quantify the hunch that something is either too regular or not regular enough. In astrobiology, contact scenarios broadened. Not only messages and megastructures, but low signature presence, curated ambiguity, reconnaissance that seeks to learn without being learned. All of that requires institutions that remember. The expertise assembled in a hurry during this encounter will dissipate unless it's housed and funded between events. Future readiness is not only better telescopes and faster spacecraft, it's people who know which levers to pull and why, habits of trust across borders, and rehearsals for the moment when a notice pings at 3:17 and the sky has put a new question on our desks. By the time 3I Atlas became too faint to claim more nights, the global community it had convened knew the work would go on without it. Seeing had led to thinking. Thinking had led to building. The next wanderer will arrive into a world a little better prepared to meet it. Curious without being credulous. Cautious without being closed. And in the steel and software that readiness will require, the memory of this season will be threaded like a quiet inscription. We learn to move faster, to share more, to argue well, to welcome mystery without surrendering method. Even in the quiet aftermath, proposals multiplied. Dedicated interstellar object watchers in space to guard the sunside blind spots. A small fleet of ready-to-fly probes on the ground, stored for rapid assembly and launch. Shared sky maps updated in near real time, open to anyone with a question and a laptop. And perhaps most quietly transformative, the recognition that science grows stronger when it invites the public to pull with it, when backyard telescopes and retired skills and student code are braided into the mainstream instead of applauded from the margins. One last practical note tied the experience together. The delays at the beginning, those weeks when a faint dot was only a dot, were no one's fault and everyone's responsibility. Software will improve, but so must our procedures. When a track looks a little wrong, the process to escalate should be short and clear. When a candidate crosses a threshold, reserved time should appear without committee drama. When a global mobilization is warranted, the machinery should whir to life with practiced familiarity. That is how we will be ready when the next 3i Atlas writes its first dim line across a sensor and we do not yet know its name. The international frameworks begun in the wake of this encounter moved from draft to practice. Memoranda formalized what the community had done informally. Who calls whom? How quickly? Through what channels? Data standards were codified so that a spectrum taken at dawn in Chile and a light curve measured at dusk in South Africa could live as one file without translation headaches. Space agencies and research institutions were developing protocols for rapid information sharing and resource coordination when potentially significant objects were detected. Those new agreements and standing protocols felt like scaffolding rising around an unfinished observatory. Practical, sturdy, and built in time for whatever the next night might bring. They were hard-won lessons, translated into muscle memory. Who alerts whom? How data move without friction. How telescope time flexes when the sky delivers an unscheduled exam. 3i Atlas had shown the best of international science, swift collaboration across borders, and it had also exposed how difficult that choreography can be when the music starts without warning. Time-critical mysteries do not wait for calendars. In parallel, another inquiry unfolded, not about the object at all, but about us. Sociologists mapped how the story rippled through cultures and languages. Psychologists studied the way ambiguity invites meaning. Communication scholars traced how a spectral line becomes a headline, then 1,000 variations of itself across feeds and timelines. Their analyses revealed a living map of our information ecosystem, how nuance can hold for a while and then thin out, how responsible skepticism either travels with a story or gets peeled off and left behind. It was both heartening and sobering. On one hand, millions of people engaged with orbital mechanics, spectra, and probability with striking sophistication. On the other, speed and scale made it hard to keep every retelling faithful to the uncertainties that defined the case. Those lessons were folded into new playbooks. If one day evidence arrives that is less equivocal, if a future discovery leans more strongly toward technology rather than geology, scientists and storytellers will need shared strategies to present what's known, what's possible, and what remains unsaid without handing confusion a megaphone. 3i Atlas gave us a rehearsal, and we learned where our voices harmonize and where they crack. As winter softened into spring and the object thinned into the background light, the circle that had formed around it began to talk about what comes next. The visitor had widened our sense of the possible. It suggested that the space between stars can carry things that sit awkwardly in our categories, right on the seam between the born and the made. It also reminded us how fleeting these windows are. The most astonishing chapters can arrive and depart before we've centered the page in the eyepiece. Preparedness, then, is not a luxury, but a method. Watch widely, classify quickly, mobilize without drama, carry parallel hypotheses with patience. The philosophical undertow of the encounter will last longer than any image. 3i Atlas. Pressed on questions we keep returning to in the small hours. What is intelligence if it can stretch across geological time? What counts as intention when intention prefers to be quiet? What happens to meaning when minds might think in centuries the way we think in minutes? Even if this traveller was nothing more than ancient ice and dust, it forced us to consider those scales, to feel the stretch in our thinking. And of course there was the mirror. Whether natural or engineered, 3i Atlas made us look at ourselves the way an outside observer might. Restless, ingenious, disorganized, hopeful. It asked how we would respond to news we cannot control, how we would govern wonder without sinking into credulity, how we would hold skepticism without leaning into dismissal. It also posed a simpler truth. We live in a universe that is stranger than our tidy explanations, and that strangeness can be kind to those who arrive with good questions. In the end, the story was as human as it was cosmic. It was about curiosity with its sleeves rolled up and humility learning to share the bench. Our instruments reached far. Our categories reached less far than we wanted. Our willingness to sit with uncertainty reached a little farther than before. And somewhere in the middle of that, a community found itself. Professionals under domes, amateurs on rooftops, students scribbling ephemerides in the margins of notebooks. If these gentle night journeys speak to you, a quiet like and a subscribe to Space Historian helps more than you might think, and it keeps these calm explorations drifting to the ears that need them. The object kept receding. Its name remained bright in our conversations while its light faded from our detectors. Still, the wake it left spread through lab meetings and lecture halls and living rooms. Curricula were rewritten to include a living case study in uncertainty. Museums designed exhibits that let visitors drive an orbit fit, compare spectra, feel how a small change in an assumption echoes through a conclusion. Students watched working scientists disagree skillfully, change their minds, and change them back as new data arrived. They saw that knowledge is not a fortress, but a scaffolding that moves with the work. Our institutions learned too. The early delay, those weeks when a faint dot was only a dot, was not a scandal. It was a teacher. Software will improve, but so must process. When a track looks odd, escalation must be crisp. When thresholds are crossed, observing time must unspool immediately. When a global mobilization is warranted, the machinery must come to life because it has done so before. Behind the scenes, memoranda turned into standing agreements. Formats were harmonized. The habit of sharing by default grew sturdier. The cultural effects were braided with the scientific. The event showed how a sky story can loosen old knots. Silos softened. Disciplines overlapped. People who never meant to love astronomy learned the grammar of light. It also revealed where our reflexes need training. We like endings. The cosmos often prefers chapters that close themselves halfway. Living with that mismatch is part of becoming a species that can meet the universe on its terms. And beneath the policy talks and the instrument specs, the oldest questions stirred. If there are minds that last for eons, how do they choose to speak, or to remain silent? If reconnaissance is a language, what ethics govern its verbs? If we ever find ourselves as subjects in someone else's field notes, what dignity will we require of them, and what grace will we extend in return? 3i Atlas nudged those questions from the seminar room to the dinner table. Economies shifted a little too. Planetariums filled, publishers commissioned, classrooms overflowed. Budgets, which are moral documents in disguise, began to reflect the argument that readiness is worth paying for. The Vera C. Rubin Observatory promises a flood of moving points. We'll need filters, statistical and institutional, to decide which ones get the full chorus of instruments. We'll also need the quiet, patient capacities that can sit idle for years and then, on some cold morning, become the most important tools on Earth. Theoretical work deepened in the background. New signatures were proposed for separating the born from the built. Information theoretic measures were tested against simulated Comé and contrived plumes to gauge when pattern stops being a trick of eye and becomes a number. Archives were reread with wiser eyes. A few old oddities stepped forward for a second look. Plans for nimble spacecraft, interceptors on a short leash, moved from speculative white papers to the early bones of engineering drawings. None of this promised certainty. What it promised was better questions, asked sooner, with more hands. It promised a culture more at ease with ambiguity and a science more willing to admit what it does not yet know. It promised that the next time a wanderer leans out of the dark with a story stitched into its faintness, we will be ready to listen in more than one language. So the visitor dimmed, and our attention returned to other skies and other problems. But the attention was different now, quieter, better tuned. We carry forward the habit of looking up and then looking inward, of letting a single point of light teach us about instruments and institutions, about doubt and patience, about the ways a species learns to share both wonder and method. And as this gentle voyage settles into stillness, perhaps you feel what so many felt in the wake of 3i Atlas, that we are small and bright and briefly here, and that the questions we ask together make us larger than our shadows. The stars will keep their posts. New stories will arrive. We will practice welcoming them with care. Good night, fellow travellers, in this magnificent cosmic mystery we call existence.